at all. But suddenly you find a new use of an element, takes it to lithium. Suddenly has simple thing like spark. What was else? What semiconductor?
Yes, sir.
Elements become critical when new uses and new inventions are comes up.
कार्ड पाखरे पड़िछि वो कार्ड पाखरे ना धरी
नमस्कार सर्वोत्तम साहब।
नमस्कार रही साहब, नमस्कार।
Seeing you after a long time.
Yeah, correct. Yeah, we are meeting after a long time. So actually, just day before yesterday on Rath Yatra day, I was just thinking about all those scenes were coming to my mind. Namaskar Rath Sahab, Shishir ji, namaskar.
नमस्कार जी।
Namaskar.
बहुत दिन के बाद।
हाँ, बहुत साल। Correct. Yeah. So.
Sir, good evening to all, sir.
चला, hey, what is that? चले.
There are a lot of sounds, sir. I think
I don't know
I
from where
request
it's coming.
everyone.
Request to participant to mute the speaker, please.
Yeah, that's necessary.
Yes, sir. I think Nanda sir, JK Nanda sir, I think the sound is coming from you. You can mute it, sir. Your speaker. A lot of sound is coming from your.
I think it is from Mr. Sahu.
Okay, sir.
Oh.
A very good evening to all of you.
Good evening, Vadhavan Sahab. Good evening. Good evening.
Good evening, Vadhavan Sahab.
Good evening, Vadhavan.
May I have your attention, please, sir? And after a break of 1 year, again we are resuming our fraternity presentation program from SGAT. I welcome all of you. May I have your attention, please, sir? I think there is some time gap while speaking. But anyway, sir, before we start today's program, I would like to highlight about our organization, that is Society of Geoscientists and Allied Technologies, SGAT, SGAT.
Yeah.
And Just to say a brief about SGAT, I would say that this is the organization we started way back in 1980, and then by the lot of eminent people, mostly from the state geological department, and also from the other organizations. And then the main focus of the SGAT is to disseminate the geological knowledge and the other related allied technology knowledge among the different stakeholders, and also promote mineral development. Beside that, also one of the
Dasav, is there any technical glitch?
I think it is okay. Only voice is not audible now, but movement of the speakers and the attendance is clearly visible.
okay. Can you hear me, sir?
Yes,
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 sir.
we can hear you.
hear you.
We can hear you.
Okay. Now I'll just finish it as early as possible. Just to say, highlight that we have from the SGAT. Okay.
Sir, please continue.
All right. So the main. Normally, we do our dissemination program from the seminars, workshop, and training, and also we also publish journals, which is a biannual, and also we publish books, the geology of Odisha, geology and mineral resources of Odisha has reached the 4th edition. And besides that, we have some flagship program that is MDAP, Mineral Development Awareness Program, and EMAP, which Environment and Mineral Awareness Program. These two are mainly for college students and school students respectively.
Yes, sir. It is audible. Please continue.
No, I think his voice is breaking in between.
No, it is very clear to me. There is no glitch in the
Yeah, there is no
audibility of the speaker.
Yeah, there is no glitch actually.
With this, a brief highlight about the SGAT. I welcome our today's speaker, Dr. Hari Sarvothaman. Hari Sarvothaman, who is also a member of the SGAT. He is also the member of the SGAT, and this particular program is mainly for the members of SGAT to speak and share their expertise.
Yes, sir. It is clear. Kindly continue, please.
No, he is speaking, but we are unable to hear part of his speech.
It appears so.
Okay, then now what I'll do is I welcome you all for the today's this virtual meeting. Today I request our
Esteemed speaker.
Today's moderator is Dr. Rajgopal Mohanty, who is a regional director of AMD. Right now he is based in Hyderabad, And I request Dr. Rajgopal Mohanty to take over from here and do the honor of moderating the session. Dr. Rajgopal Mohanty, sir.
Thank you very much. Am I audible to everyone?
Yes, yes, yes.
Yes, sir. Yes, sir. It is audible.
In fact, I thank Dr. Sarvothaman Das. What I am seeing is that everybody attending this program are known to each other very well. I am little misfit in this group, but anyway, I am also a geologist, retired as additional director from IMD, Hyderabad. Probably the back of the mind was we are also working for rare earth. That is the reason why probably he has and they have decided me to become a moderator. But certainly, before I say something else, I'll read out for for the information for all the people who are attending the bio data information of Dr. Sarvothaman. I find in the crowd probably there is no one except only few who do not know him. But even then, as a matter of what you call ritual, we should know and what has he particularly what has he done after post retirement. Dr. Sarvothaman, in fact, he joined professional career in ONGC in 1976. After that, he joined GSI in 1977 and continued, retired in 2012. His main areas of work was in Assam, West Bengal, Karnataka, Andhra Pradesh, Tamil Nadu, Telangana, Kerala, Goa, Odisha, in the Himalayas of Arunachal Pradesh, Bhutan, Uttarakhand. So probably almost half of the country divided in the northeast, southwest direction. And his areas of interest were exploration, natural resources research, petrology, geochemistry, remote sensing, environmental study, compilation, editing, scientific publication. So editing scientific publication is the greatest work probably he has been engaged in the post-retirement activities. He has 60 odd scientific publication, few of them in international journals. He is also an author of 4 textbooks. That is wonderful. In fact, that is an achievement probably for any geologist to complete 4 textbooks on water, environment science, disaster hazards, which are used for college and universities. That is true, in fact, commendable work. And he has got international exposures and gone from the Ministry of Mines. But most of everything, the University of Hyderabad is at benefit. They have roped him as a visiting professor where he is disseminating his knowledge, and also a guest faculty in Engineering Staff College of India and Bhadruka Group of College in Hyderabad. He has been researching in critical minerals. Probably he was, I do not know. He may be associated with the what you call establishment of critical mineral mission of India. So that maybe he's one of the main contribution. And beside that, for the society, also he is doing a great work. That is, he is running an NGO which is also contributing or giving education for education center. That's an NGO name is Vivekananda's Educational Center that manages Vivekananda Public School. And most importantly, there is no fees for the less privileged children. So this was actually his base, mostly the bio information, the utility information. But the topic he has selected today for the fraternity group of SGAT is very, very contemporarily important. And it's such a subject which is evolving, or the criticality of those minerals may be ever changing. So today is a critical, and maybe after a few months or so, it may not be critical. So that's why all the things he will be discussing, but his lecture was confined to the critical minerals in probably semiconductor applications. So I will not take much time. I'll give it to the floor to Dr. Sarvothaman to start his lecture, and for the question answer session will go later on. I will request all the participants to write in the chat box. Either they can write a question, or you say I want to ask question. That's all, because sometimes writing questions may be a little difficult for all the seniors. So many retired people. So maybe typing will be difficult, but you say that in chat box I will I will ask a question. So we will go one by one after this as per the seriality. So now with this, I give the floor to Dr. Sarvothaman, please. Please, Dr. Sarvothaman, you can share
Yeah,
your slides.
yeah. Thank you, Rajagopal Mohanty sir. Thank you, Jayenda sir. And namaskar to all my seniors who are sharing the stage with me. And I thank SGAT and IGO for giving me this opportunity to just to share with whatever I have learned in this last 2 years on the semiconductor aspects of it. And with this, I will straight away I will straight away come to the subject and share the screen. Now, ladies and gentlemen, today's topic is critical elements and metals in the semiconductor sector, Indian perspective. Mostly, I am restricting myself only to Indian perspective. You know very well, in the year 2013, India Semiconductor Mission was initiated by the government of India and government of India, and this is a special mission only focused towards semiconductor. So this is the screenshot of the portal of the India Semiconductor Mission. You can it is run by Digital India actually, and then it is government. Digital India is a part of government of India. So anybody who wants to more see all these things which you are going to discuss this evening are available in this semiconductor mission. But I have gone a little deep into the subject, and as geologists, what are we supposed to do to contribute to the semiconductor mission? So with these few words of introduction, let me come to that. So now today, ladies and gentlemen, today you can see the semiconductor chips have applications in many things, right from consumer electronics, automotive manufacturing, medical devices, embedded systems, smart home appliances, and renewable energy technology, which is a very, very core sector of the engineering. Okay, so let me briefly tell you about what the three things here: semiconductor, chip, and integrated circuit. We need to understand all the three in the beginning itself. So let me go straight into semiconductor. Semiconductor is an earth material or resource in the form of an element or a metal. Whereas chip is a carrier of electronic components manufactured using the semiconductors. And the integrated circuit is a product that integrates multiple electronic components onto a chip. So these three are related, but the most important, the fundamental is a semiconductor material, which are important for the making the chips and integrated circuits. And semiconductors allow conductivity that ranges between a conductor such as copper and aluminum and an insulator like rubber, plastic, and ceramic. That's the reason it is called semiconductor. They work both as a conductor and insulators, depending on where they find in the entire chip, integrated circuit and the chip. So they are the medium to control electric current in the electrical appliances. All these applications, right from consumer electronics to renewable energy source, they are the medium to control the electrical current. That's most important. That's the way they have achieved today. They have achieved the standard they are now. Okay. Now, if you look at the periodic table, the semiconductor elements and their locations in the periodic is given here in the they are shown in.
Excuse me, Dr. Sarvothaman, you can make it a slideshow so that view will be better.
Yeah, this is slideshow. I'm showing the slideshow only.
Is it slideshow? Okay,
we are slides. No, the slides are not moving. You have to
Slides are not.
Yeah, so you can make it a show. So that's in the bottom you have a cup-like thing, no? So
no, hold on, guys. First, he has to move to the next slide. So
no, it has not. No, it is not occupying the full screen because when you see the
who is operating the slides? Who is operating the slides?
So he himself is operating.
Yeah, now it has moved.
It has moved, but it is not at the full screen.
It's not the moving.
It has rather jumped.
The full screen.
It is not
Yeah.
not full screen. You make it full screen by that.
Yeah.
Yeah.
Yeah, right.
Okay.
No,
No,
you
no, not yet.
please enlarge.
Not
Yeah,
happening.
it is it's not happening.
No.
No.
Happening, not happening. Anyway, carry on. So that no, that is one way, but we
Yeah,
can make it
but I'm trying to do that. Has it
uh,
come now? Full screen? Full screen has come?
no, no.
Sir, please go to view slideshow. There is a slideshow tab on top.
Yeah.
Do you
Yes.
see this?
Okay.
Slideshow?
Okay.
Yeah. Just
the-
click from current slide.
On the bottom
That's
right.
Has it come?
just
No.
once. No, you have to click it.
No, it is still showing the.
No, just click it
No,
once.
you just tap the right button on the top square, so it will enlarge on your laptop.
No.
No.
Yeah, that one will do, I think.
So,
From the beginning?
Yeah, from the beginning. Just do from the beginning. Let's see if it moves. No, it's not happening.
Maybe something in his own system.
That's okay. Sir. Just go ahead. Let's go ahead.
Okay. Yeah, this is I will share. I will share in this mode only. Okay. If you all agree, I will share it in this mode.
Done, sir. Please go ahead.
Yeah, that's fine. That's fine.
Yeah. Okay. So if you look at the periodic table, the elements and metals which are shown on, some of them are non-metals, non-metallic elements also. They occupy what as the space shown in deep yellow, like this aluminum, silicon, all these things. They are and these are the elements which go into the chips and then into the integrated circuit. Okay. And coming back to the India Semiconductor Mission, ISM, it is a specialized and independent business division within the Digital India Corporation. It aims to build vibrant semiconductor and display ecosystem. Not only semiconductor, in the display ecosystem also, to enable India's emergence as a global hub for electronic manufacturing and design, both. Please remember this, electronic manufacturing as well as design. Design is the one in which you have so many chips put together into an integrated circuit. So India is going not only for the electronics manufacturing, but also designing. See, designing requires a lot of efforts to go into, the emergence, the global hub. It's a very stiff competitive market today, both electron manufacturing and the design. So that's the reason some of the countries which are very good in both, they have reached at the top of the hub. So India is now in the process of becoming a leader in both manufacturing and the design. That's all short about the India Semiconductor Mission. So in this context, semiconductor elements, antimony, arsenic, boron, carbon, gallium, germanium, selenium, silicon, sulfur, and tellurium are needed. Let me, at the outset, let me make it very clear to you. These are the elements which are required in the semiconductor sector. And many of the above elements and their host minerals are critical today. All the minerals, all these elements, of course, and the minerals which contain these elements, they have become critical. So some of you may ask, what are the critical minerals? For your benefit, the elements and minerals which might impact the economy and face threat to supply. Suppose we are not getting carbon for some reason, carbon turns critical. Suppose we are not getting tellurium turned critical. So both economy and supply chain has to be disrupted. Economy has to get affected, and supply chain has to be disrupted. Then it becomes critical. Some of the strategic minerals may be critical, but not all. For example, I happen to be in the tungsten committee of DMRL. So when the Chandrayaan 2 was going on, they wanted some tungsten immediately. it became very critical. So in the end, Chandrayaan-2, for Chandrayaan-2 only, they imported quite a lot of tungsten from some other country, which made a very big dent on the economy. So that became critical at that time. Even now, it has criticality. Then, in addition to that, elements for essential development and strategic programs that are likely to face disrupted supply become critical. For example, today we are having BrahMos. So many elements and metals are going into BrahMos, and a lot of spacecrafts. ISRO is almost every month they are sending spacecrafts. So many of the very high tensile stress and very high temperature minerals are necessary, which can withstand corrosion. They are required, so they also become critical. Tungsten is one, magnesium is one, and there are quite a few of others also. So this is all about the critical. So if the elements and minerals impact the economy and face threat to the supply are critical. It can be anything. It can be any element. It is only the purpose for which we require them. It is very important. Okay. So therefore, who are the stakeholders in the India Semiconductor Mission? Let us see. The number one is electronic engineers and technologists. They are the major stakeholders. Mineral engineering practitioners. Why? We will come to a little later, because it is the mineral engineers who are liberating all these elements from the crystal lattices of the minerals and make them available to the semiconductor mission. So therefore, mineral engineering practitioners are the biggest practitioners in the semiconductor mission. Then we have analytical chemists who analyze the earth material and find out which material contains what. They are equally important. And finally, we, the geological professionals. Why? Because we are specialists in the field map. Those who are specialists in the field mapping, petrography, geochemistry, petrochemistry, thermodynamics, and mineral exploration. We are all the stakeholders in, because if we do not find which we do not make the semiconductor elements made available to the India semiconductor mission, it is going to be, India has to import quite a lot of them, like germanium, gallium, and all that. It is going to affect the economy. And then the supply chain also has to be continuous. Otherwise, the supply chain, if there is disrupted, it becomes very critical, and then our semiconductor mission may face some problem. So both the supply chain disruption wise and economy wise, the elements which are required in the semiconductor mission is going to be affected. So we should see, as geologists, we should see that the elements which are required in the semiconductor mission are continuously made available to the mission. That's our job, by using our field mapping to identify the minerals, petrography, geochemistry, so on and so forth. I don't have to tell that. Now, it was started, as I said in the beginning, the mission was started in the year 2013. In just a few years, India has managed to draw the attention of global chip majors. Yeah, we had made a very deep dent into the major chip majors, global majors actually. So we already have Tata Group on Taiwan company, 91,526 crore in Tholera, Gujarat. It will start production by 2026. Micron Technology, United States, at Sanand, Gujarat. ATMP, that is Advanced Therapy Medicinal Products, they are manufacturing. And memory package for the testing they are making. Then Foxconn and HCL, Indian Foxconn of some other country, I think United States, I'm not very sure. HCL, our own HCL, they are making 3,700 crore driver at Jewar, Uttar Pradesh. It is recently approved. It has started coming up. Then we have Tata Electronics. They have started one unit in Assam near Kaziranga, that very famous national national wildlife sanctuary. It's advanced packaging, same ATMP. That is all medicinal products they are making to set up by mid 2015 it will start. Then CG Powers, Renesas, it is also a joint venture, and then Stars Microelectronics. They are starting OSAT facility at Sanand, Gujarat. OSAT is nothing but outsourced semiconductor assembly and test. They are also making, there's only assembly. They are also making a very big contribution. That's also Sanand, because Sanand, Gujarat is already having another unit in ATMP facility. Probably the assembly facility at same Sanand will go into this ATMP facility later. I think that's how they have made it. And then Keynes Technology, another OSAT facility at same Sanand, Gujarat, because it is going to be very, very huge type of production. The semiconductor, this medicinal product is going to be very, very huge. So they have 2 units at Sanand, which will supply to the medicinal products. So besides this, we also have recently, there are facilities thought about at Orvakal near Kurnool in Andhra Pradesh and Panvel in Maharashtra. That is in the near New Mumbai. It is starting. It is just about 2 or 3 months back they have started that. So we are in different stages. So some of them will start giving the products by mid 2025 and early 2026. So we, in a short time, the mission has produced very fantastic results. Now, semiconductor and metals, these are the general traits. As I said, it is antimony, arsenic, boron, carbon, germanium, selenium, silicon, sulfur, and tellurium. Some of them are very, very common, like carbon or sulfur. They appear to be very, very common. But then for the semiconductor type of work, they require a little more, many more tools, fine tuning actually. And silicon forms the basis for most of the ICs, integrated circuits. They are the base for most of the ICs. And common semiconductor compounds like gallium arsenide, indium antimonide, and oxides of metals have properties like electrical conductivity and resistance to rising temperature. These are the common things which all the semiconductor needs to have, like electrical conductivity and resistance to rising temperature, because some of the semiconductor chips and integrated circuits which are used in some of the instruments will have to stand very, very high temperature, maybe 750, 800 and all, especially in the automobile and aircrafts and space shuttles and all these things. So they have to have both the conductivity as well as the insulation properties. Resistance to rising temperatures, nothing but insulation. Okay, so they are placed between 2 main kinds of elements, that is conductors and insulators. So the elements, they need to have both the characters of both the conductors and insulators. Conductors have electrical conductivity like copper, and the resistance increases when the temperatures rise, whereas insulators like glass have low resistance when the temperature rise, and they are not good at electrical conductivity. So these are very small, very well-known things, but I'm sharing because I just wanted to keep in, sort of loop with you to share to understand much faster. Semiconductors work due to the imbalance of electrons that carry negative charge. Electrons. So they carry the negative charge, and electron imbalance leads to positive and negative charges at 2 ends of the conductor material. That's the reason, both positive and negative. So that gives them the conductor insulator characters. Okay. Now, by adding impurities, by deliberate adding of impurity to semiconductor, a process which is called as a doping. Many of you are maybe aware of this word doping, but this doping is very common in the semiconductor industry. By doing this, its electrical, optical, and structural properties are changed. All the three, electrical, optical, and structural properties are totally changed. Doping is to control the conductivity of semiconductor and change the number of the charge carriers, that electron which they carry. The moment you add, by you do the doping, the number of charge carriers will change, so they become either conductor, or if they change to a negative way, it becomes insulator. Most common dopants are antimony, boron, phosphorus, and arsenic. They are called dopant, but the process is doping, and the material used is called dopant. Okay, and there are two types of doping. One is P type, that is positive type doping, creates an excess positively charged holes in the crystal lattices, and N type, that is negative type doping, increases number of mobile negative charge carriers within the semiconductors. So in doping technique, dopants are added to silicon crystals. We will come to a little, there are visuals for this. How it is done, we will come to know. So added to the silicon crystals are implanted to semiconductor or introduced by diffusion. So these are the three processes in which the electronic people are they are good in doing all the three. They are either added to the silicon crystal or implanted. Very small quantities of dopants are implanted into the semiconductor material or introduced by diffused. They are diffused within the semiconductor product. In P-type semiconductor, P for positive, a small portion of dopant atoms results in millions of holes, which are positive charge carriers in a semiconductor. The moment a P semiconductor is introduced as a dopant, millions of holes will appear. That gives the positive charge to the semiconductor. Whereas in the negative N-type conductor is doped with pentavalent impurities to increase its conductivity by adding free electrons. Okay, so N-type is always better as it reduces light-induced degradation and increases the durability and performance of the entire semiconductor. So this is about the process. It's not our cup of tea, but then the process is to be known to us. How this is a dopant, because it is a deliberate addition of the impurities to the semiconductor, which is certain. It is a P and N type, and how it is made, that is explained. Now, silicon is the basic of all the semiconductor chip manufacturing. You can see how a sand, by passing through the electricity, is becoming a silicon, and from this the wafers are cut, very very thin wafers are cut, which go into the chip. These wafers go into multi-layers into the chip, and the multi-layers will have different types of semiconductor elements. They can be even insulators, semiconductors, semi-insulators, or anything between the wafers. Okay, so a silicon atom has 14 electrons and around nucleus. There are 4 valence electrons in the outermost orbital. When silicon is made into a single crystal, it can be used as a material for semiconductor products. This is the most important. So the importance of silicon, which is abundant on the earth, we can see how when it is made into a dope, when it is doping is done, how much of character changes, you can see that. So electricity for most part does not conduct in the pure silicon state. That's very important. Silicon is doped with impurities, transform it conducting. This is very most important. That's the reason I highlighted this with another silicon doped with impurities transforms it to conductivity. For example, silicon carbide, SiC, is a semiconductor where you use the silicon and carbon. SiC provides a number of advantages over silicon. So instead of using the complete this silicon wafer, we can use SiC, silicon carbide, as a semiconductor chip into that. Okay, it improves the performance of the semiconductor chip. Metals in high-tech areas and niche areas like gallium and germanium, they are the most important things. Metals are used in high-speed computer chips in defense and renewable energy sectors. We know it very well. There are many alloys instead of metals. Sometimes, most of the time, not sometimes, most of the time, the metal alloys are used in the computer chips in defense technology, and because the idea is to make them very light, so that they can be propelled into the atmosphere very fast with light weight, and also the payload can become much less in weight, as well as they can withstand very high tensile stress when they are propelled into the space. These are the things which are needed. So for that you do all these techniques. Germanium is the key to fiber optic cables and high-speed computer chips and plastic, as well as infrared radiation. So germanium is a very, very important metal element in the entire game, semiconductor game. And another is gallium. Gallium and germanium and their oxides are used in defense applications like night vision devices. When we have to do, undercover in the night operation and all that, you have night vision devices as well as satellite imagery sensors. Both gallium and germanium are used. They have very tremendous application, defense applications. They are important for low carbon technologies as solar cells. Semiconductor wafers made with gallium arsenide rather than silicon can operate at higher frequencies and are heat resistant. They are highly resistant. This information I have taken from Wafer World of United States of America publication. So the gallium arsenide rather than silica, they can operate at higher frequencies. If you go to the what you call the spectrum, we can know how much higher frequency and all that, and they become also heat resistant. They produce less noise than silicon devices, especially at high operating frequencies, making them useful in radars. Now with the recent showdown with our enemical nation, how radars are very important. All of you, I don't have to go in deep into that. And radio communication, these are all very important today. Satellite. See, this is one reason how we were able to do all these things: radars, radio communication devices, satellites, and LEDs, light emitting diodes. They are all possible with the semiconductors, the two gallium and germanium. So you can understand the importance these two play, gallium and germanium, in the current semiconductor scenario in India. Okay. For example, let us discuss something more about the germanium. Germanium ores are very rare. Of course, you know it very well. It's a byproduct of zinc production and from coal fly ash. So now those who are in the coal mining, they have to look for germanium within their, overburden or anything like that. Silicon is less expensive substitute for germanium and electronic application. That's what USGS says. And zinc selenide and germanium glass substitute for germanium metal in infrared application system, but often at the expense of the performance. Okay, so germanium has got much, if it is used with, directly instead of with zinc selenide and it has got better performance. So therefore, as geologists, we have to do the petrography and exploration for these minerals have to be stepped up. What are the minerals? Germanium is the germanium with ore with gangue. Germanium and its minerals. This is ultra pure germanium. This is how it looks, ultra pure germanium. And what are the two main germanium minerals? Germanite, that is copper, iron, germanium sulfide, and RG rhodite, that is silver, germanium sulfide. These two are very important. Then this is the thin section of ore which contain tannantite and germanite. You can see this is germanite with sphalerite spindles within that, lamellae within that. So this is the type of things which we are looking for when we are talking about the germanium. So who will do that? Excepting geologists. The finding of this type of ores is the geologist's job. Nobody else can do that. That's the reason semiconductor mission, we are one of the topmost stakeholders. Our responsibility has increased with this type of studies where you go for this to identify the germanite in the thin section and also the complete minerals in which other elements within that, and then go for extraction of these minerals from the mines. Geology of the germanium minerals, let us go a little deep into that. Germanite, that is, it's a sulfide mineral, forms in hydrothermal polymetallic ore deposits and skarns, often associated with the dolomitic rocks by circulation of mineral-rich fluids that precipitate various sulfide metals. Like, we know the hydrothermal processes, and we have studied, we have dealt with also, we have come to that type of occurrences in the field also, but let us refresh our memory. They are the skarns and hydrothermal polymetallic ore deposits, because germanite is found alongside minerals like rhynerite, pyrite, tannantite, enargite, galena, sphalerite, all sulfides, digenite, bornite, and chalcopyrite. This information has come from Azo Mining. They are suppliers to the semiconductor missions. So I have taken it from the reference from there. So all these minerals. So whenever we have some chalcopyrite or bornite and digenite or even sphalerite, we have to look deeper nowadays. In ore microscopy, if we find any of this, we need to see whether germanite is available or not. There can be even small lamellar application, but then we can definitely recover the lamella from the main body. Availability of germanium in hydrothermal fluids and approximate redox condition that enables its incorporation into sulfide matrix are important. So Namibia and DRC, Democratic Republic of Congo, have occurrence of germanite. And coming to India, yes, Rajpura and Dariba prospect in Rajasthan is a potential place where germanite can form germanite. So we have to revisit Rajpura, Dariba, and for that matter, any place where all this stuff is available. There is a digenite, bornite. See, these are all very common ores like sphalerite. There are very common sulfides, chalcopyrite, tannantite, pyrite, and all these things. So wherever these are available, we need to revisit again. That's the importance of the geologists. So the organizations like GSI have to launch, spin-off items, field items to go specifically to explore this type of germanite and all these things. Today, if we stockpile germanite for about 3 to 4 years, countries like China will fall at our feet because they are our competitors right now. So it is necessary that we stockpile germanite from the minerals and all available minerals. Okay, so we can start with the Rajpura Dariba. Then we have RG rhodite, silver and germanium sulfide occurs in low temperature hydrothermal silver bearing veins. You know very well some silver bearing veins are available in the Aravalli. I mean, I'm not very sure in the Rajasthan area which formation I cannot say, but like it occurs with other sulfide minerals like galena, sphalerite, and tetrahedrite, and sometimes with the tellurites. Tellurites are also very important. We have to look for tellurites. Okay. Now let us shift our focus to gallium. Gallium is liquid at temperature greater than 29.76 degrees centigrade. Okay, so the recovery of gallium is very, very tricky because it occurs mostly as a liquid at that temperature. There are issues, therefore, there are issues in recovery from the source. Gallium is used in the electronics. Gallium arsenide, primary chemical compound in electronics, is used in microwave circuits, high-speed switching circuits, and infrared circuits. So they are so important, gallium. So we have not been, see, we come across so much of information now when we do this type of study, what type of stuff is used in the semiconductor, we come across all these things. I do not know really how much of gallium has been, used up for other purposes now or simply thrown away. So, but today gallium is such an important thing which is going directly into the semiconductor mission. So, like microwave circuits, then radars, microwave, they're all high-speed switching circuits and infrared circuits and all that. Then semiconducting gallium nitride and indium gallium nitride produce blue and ultraviolet light emitting diodes and diode lasers. All the laser industries which you are finding now, they're all using gallium nitride and this type of thing. So this is the wafers of gallium nitride. You can see how they are the dope. They are the after doping. Then gallium arsenide, and this is gallium arsenide is like this, and the chip looks like this. So gallium is not a free element in nature, as you know very well, but gallium-3 compounds in traces in zinc ores. So, where example sphalerite. So, wherever zinc is available now in the field, we have to revisit all those areas and see whether gallium is also available along with the zinc ores. And not only zinc ores, it's available even with the bauxite. So, this is where our responsibility increases. Apart from aluminium, we need to focus on gallium also from the bauxite. So bauxite, which you have been thinking as very, we have abundant now, suddenly the focus shifted to the semiconductor industries. Recovery of gallium from bauxite needs innovation because most of at greater than 29.7 becomes liquid, therefore it requires innovation. Its recovery needs innovation. Gallium is used to make alloys with low melting points and in semiconductors as dopant and semiconductor substrates like this. Gallium is a byproduct of processing of aluminium, zinc, and copper. Gallite, this is gallite. It has copper, gallium sulfide. It's a sulfide and gallium bearing mineral. Gallobutandite. This is that. Gallobutandite, that is lead, gallium, arsenic, sulfate. So this is also important mineral for gallium. And sumgallite is this one. That is gallium oxide with hydroxide element within that. So it is the necessity of the geological community to very closely look at. We in our times when we were in our prime time in geological survey of as a professional geologist, we never even thought of, we never even heard, to be very very frank, I never heard about this type of minerals, but suddenly these minerals have come somewhere from the board, from like a board from the blue, and they are ruling the world in the semiconductor business. So they all have become extremely critical. Now we have to see whether they are available in the shores of India now. Okay. Now to drive the point, why they have become critical. Let us see what happened in United States. Imports of gallium metal and gallium arsenide wafers in the year 2022 were worth about $3 million. Can you imagine? Gallium metal is $3 million and gallium arsenide doped substance, it was $200 million in USA. Gallium metal is 3 million and gallium arsenide is 200. A semiconductor producer. It gives a picture about the gallium market of today in the year 2000. It's a huge market. It's a very huge market. So therefore, how if India has launched the Indian semiconductor mission, this is the type of money which we require to obtain the gallium and gallium arsenide for our semiconductor industry. So it is our responsibility as geologists and earth scientists to find out all these minerals in the rocks of our own India, so that we can directly mine them and use them in our semiconductor mission. High purity refined gallium production last year was about 290,000 kgs in 2020. Just imagine, 290,000 kgs, an increase of from 250 kgs in 2020. It is always, the demand is always increasing. And if India has a semiconductor mission, this is a similar picture which is going to emerge in India also. Therefore, we should be prepared. So again, before the government pulls the geologists up and say, what have you done for the semiconductor industry? We, the earth scientists, have to, pull up our socks and try to do something very much important. In some applications, gallium in arsenide wafers can be replaced by silicon or indium. This is a very good news, but then the replacement is only a substitute. But original materials used cannot be replaced. Okay. Now, let us talk about aluminium. Aluminium itself is not a semiconductor, but crucial component in the semiconductor industry. Let me read through it because we are also more than an hour into the meeting. Aluminium nitride, ALN, and aluminium gallium nitride, ALGAN, and aluminium gallium arsenide are semiconductors. So, by doping aluminium with gallium and either nitride or arsenide, you can get very good semiconductors. Aluminium itself is not a semiconductor, but use aluminium as a base and dope it with gallium nitride and then gallium arsenide, it becomes very good semiconductor. That's a good news. Yes, we can try to get some of this stuff within our India. Aluminium silicon alloy, ALSI, improves properties for a few applications in semiconductor manufacturing. Aluminium is used to construct vacuum chambers essential for sputtering process in semiconductor manufacturing. So that's there also aluminium is very important. So aluminium can act as a P-type dope. There's a positive type of dopant in which millions of the holes are created in semiconductor material. Introduce holes, yeah, this is what I would say. Introduce holes and alter the electrical properties. By introducing the holes, the electrical properties are altered. And aluminium nitride is a wide bandgap semiconductor with potential for high power and high frequency applications. Can you imagine high power and high frequency applications like radar and all that? Okay, so aluminium gallium nitride alloy is varying aluminium content in useful optoelectronic devices, optical and electronic devices. devices, which are very well used in most of the industries today. Aluminum gallium arsenide is a semiconductor alloy with larger band gap than gallium arsenide (GaAs) used in lasers, light emitting diodes, and other devices. So we in India, or at least we are not finding criticality in terms of aluminium. We have a lot of aluminium both in Odisha and Andhra Pradesh. So we should make use of the best use of aluminium and dope with gallium and arsenide, and that becomes a very good semiconductor. But again, it's the industries which have to do that. All the doping processes is done by the electronic industries. Aluminium, indium, yeah, that's what we have to do. Yeah, aluminium indium arsenide is a semiconductor with larger band gap than indium gallium arsenide used in high electron mobility transistor (HEMTs). Aluminium gallium indium phosphate (AlGaInP) is a semiconductor used in visible and infrared lasers. See how much of versatile things these are. Visible and infrared, near infrared lasers. So they are very much used in our, sensors which are used in the payloads of the spacecrafts. So that much of versatility these things have. Okay. Thus, while aluminium is not a semiconductor, its conductive properties and the existence of aluminium containing semiconductor compounds make it indispensable to the semiconductor industry. This is the most important thing which I wanted to drive the point today. Well, aluminium may not be a semiconductor, but then when you introduce conductive properties, the existence of aluminium containing semiconductor become very much indispensable, because you see how much of wide applications, visible and infrared lasers and HEMTs and LEDs, everything, name anything, it is there. Okay. Now let us discuss something about this aluminium gallium nitride, which is used to manufacture LEDs operating in blue to ultraviolet spectral region, wavelengths of 250 to 222 nanometer, that is far ultraviolet regions are achieved. So they are used as in the sensors of the space applications, used in blue semiconductor lasers, detectors of UV radiation, and aluminium gallium nitride, high electron mobility transistors. Aluminium gallium nitride is used together with gallium nitride and aluminium nitride, forming heterojunctions in any of the chips. Availability of aluminium nitride crystals.
Please mute your microphones.
Okay. Availability of aluminium nitride crystals and wafers in sufficient size and quality is the key for manufacturing high performance electronic devices. Ladies and gentlemen, remember, aluminium nitride crystals and wafers in sufficient quality and quantity, size and quality is the key. So how much it is aluminium nitride is important. This is the aluminium nitride, the first aluminium nitride crystal, 43 millimeter. It requires a lot of processing. It is just not, it is possible, because if we our own expertise, if we make it aluminium nitride, this will be the clinching point for the entire semiconductor mission. With this, we can make very, very thin chips, both sufficient size and quality. Okay. Aluminium nitride as semiconductor offers extreme field strength, high material quality, low defects, and good thermal conductivity. This is the quality of this thing, aluminum nitride. Extreme field strength, high material quality, low defects, and good thermal conductivity. Special physical properties make aluminum nitride based devices achieve performance beyond silicon carbide and gallium nitride in power electronics. Wherever power sector is also there, the semiconductors are used in there, and gallium nitride is used in the power electronics. Like our windmills also, like it requires a lot of gallium nitride semiconductors and all that. And aluminum nitride is suitable for processing of super low loss power transistors and has potential to be ultra wide gap UWPG semiconductor for power electronics. These are all used in the power sectors. See, today power sector is also one of the critical sectors. They are also struggling. Power sectors are also struggling because their energy transition is in the top now. Today, that is a top. They have to transit from the thermal power to the solar and wind power and all that. So this type of things, some semiconductors are used in all those things. That's the reason the semiconductor mission has a very wide importance in present day time. Now, there are a few more things which are in the semiconductor mission, that is sulfur, selenium, and tellurium. Sulfur is an insulator. Yes, we require equally whenever we are doing any semiconductor, we have to use insulator also, because without insulator there will be there will be splurge. I mean, what you call, there are surges in the electricity. So insulators are very much important. Selenium and tellurium are semiconductor directly. They can be used as a semiconductor directly. Trend for non-metallic to metallic character upon going down the group is exemplified by the conductivities of these elements. Okay, the conductivities of sulfur, selenium, and tellurium increase with increasing temperature. Behavior typical of the non-metal. That's the reason they find used in the semiconductor industries. They increase with the increasing temperature. Conductivity increase. Otherwise, it doesn't happen. The moment temperature increases, they become insulators. Whereas sulfur, selenium, and tellurium, when the temperature increases, they become more. They increase with the increasing temperature. Then we have copper and zinc. You know very well, they are conductors. In view of but they are very much useful in the semiconductor industry. To follow a reason, which we'll just briefly discuss about it. In view of conductive property, copper is used as interconnects between the elements of integrated circuits. That is the reason, though copper is a conductor, it is used as the interconnects. It minimizes propagation delays and reduces power consumption. When we use the copper at the junctions, interconnects, then zinc oxide is a semiconductor having wide indirect band gap of 3.37 electron volt EV and high excitation binding energy of 60 mega electron volt MeV. This is from there's a reference for that. In addition to its electrical and optical properties, zinc oxide is known for its mechanical strength, which makes it very special. Zinc oxide, it gives so much of mechanical strength and stability, making it reliable material for the semiconductor devices. Zinc oxide. See, we think all the years we never thought that all these materials will, they will get this type of standard, status one day. But today, everybody is talking about the semiconductor and then semiconductor resources and all this. So, in that way, very unimportant, which we thought as unimportant, like zinc oxide, they have become very important materials today. Its wide band gap allows it to operate at high temperature and in harsh environmental conditions. So, a very known product like zinc oxide has so much of qualities which is used in the very high temperature and harsh environmental like space technology. Okay. Now selenium, many of you have seen this type of things. They are called as
Excuse
a
me.
photo.
Excuse me. We are
Yeah.
already 1 hour into the lecture. So please.
Yeah. I will just another 1 or 2 are there. I will
Okay.
finish.
Okay. Thank you. Thank
Okay.
you.
So
Thank you.
selenium, selenium is also one of the important. You might have seen this type of photo cells. In selenium is a semiconductor and is used in the photo cells like this, which are operating semiconductor photoconductivity. That is it conducts the light. Photo means light, and the conductivity of the light it uses. Selenium is used in the few types of DC power surge protectors, as I was telling, because suddenly there will be surges in the electrical circuits and all. It is protective to that. So, but only a disadvantage is that it is a little toxic. We have to be very careful about using the selenium. These are the selenium compound. Selenium is found in the sulfides, like can be associated with volcanic activity and sedimentary. These are some of the things. I am not going very deep into that. These ions of selenium. These are all. You can see they can be directly used as the for the chips, for making the wafers, not chips, wafers. Okay. And then phosphorus is also very important. Phosphorus availability in the element is crucial for semiconductor industry. Then why it is a electron? Phosphorus has 5 electrons while silicon has 4. Extra electron become free charge carrier. That's the reason it makes it very important. When P is, that is phosphorus is used with in silicon, it replaces some of the silicon atoms in crystal lattice. That makes phosphorus very important. Okay. Then there are some more. I'm not going very deep into that. Kindly note: indium, cadmium, arsenic, and antimony. They are also a different type of. They have different type of properties which make them useful in the semiconductor industries. So we can look for when we are doing the geological mapping. We have to look for the minerals which contain indium, cadmium, and all those things. In summary, as geologists, it is our main objective to ensure semiconductor element security. That's very important. That's what I want to say. Okay. As geologists, we should not think that semiconductor we have no stake. We have stake. It is our main objective is to ensure semiconductors element security. What you understand by security? Security means it would involve constant supply of source material for the semiconductor. How do we do that? It is our mapping, it is our petrography, it is our identification of all the gallium, germanium, and zinc and that type of elements. It gives security to the semiconductor mission. Innovative methods for recovering gallium from bauxite mines need to be worked out. This is very, very important. Innovative methods for recovering gallium, because as you said, it is at high temperature, becomes liquid. So we have to look for how the processes by which gallium from the bauxite is recovered. Germanite association with other Indian sulfide ores need to be probed. As we said, germanite is a sulfide associated with the other sulfides, so they need to be probed. Geological mapping needs to identify hydrothermal and skarn deposits for germanium sulfides. This is very, very important. So many people think that geological mapping is not is very waste. It's only it takes out a lot of energy and all that. No, geological mapping is the backbone for anything. Otherwise, we will not be able to identify the hydrothermal and skarn deposits, which are the hosts for the germanium sulfides. They are, in fact, they are the basics. Okay. So, nanotechnology, if necessary to isolate microscopic germanite, has to be done. Is also very important. And coal field ash needs to be examined for germanium and other semiconductors. technologies for aluminum nitride and gallium nitride. You have seen how versatile they are and how much of applications they have, aluminum nitride and gallium nitride. So technologies for aluminum and gallium nitride and other semiconductor alloys need to be innovated. So thank you very much and for your patience hearing. Thank you very much and namaskar to all.
Thank you, Sarvothaman Saab. It was, in fact, excellent information gathering. As a geologist, definitely we have to see the resources and how the extractability. So that is the main thing of the requirement of this thing. As you said correctly, in our time, these minerals were not known. We are not knowing about. Mainly, whatever mineral is visible to the naked eye, probably we are going about that. But now these are the minerals which are not visible. So therefore, you have to have the analytical tools to detect and know. But before that, there may be some of the queries in people's mind. All are probably your friends. You know them, and they know you very well.
Yeah. I know.
So I will go by the seriality, and then first is Girja Mahapatra, Mr. Girja Mahapatra. He's our elder brother. He says, good presentation, Dr. Sarvothaman. Are we self-sufficient in all elements and metals in India? That's a very good thing. What area need to be thrusted for geological exploration in India? Are we extracting any compound meant for semiconductor? Please, your answer.
Yeah. Thank you, Girija. Thank you very much. Thing is, as I said, bauxite, yes, we have plenty, but then how we recover the gallium from the bauxite is really, we have a lot of bauxite right in Odisha as well as adjoining area in the Andhra Pradesh. We have a lot of bauxite caps. But how we recover gallium, which is an important semiconductor stuff, is our innovation. We have to find out that. And then we have a lot of sulfide deposits. Yes, Rajpura Dariba is a very well-known deposit. You have Malanjkhand. Okay, so we have to reorient our exploration programs as well as the SCM, for example, scanning electron microprobe and all that to identify very minute minerals like germanite and all these things. They are the very important. So the thrust should be for very focused, highly focused work for semiconductor vision. GSI is already working with mission mode. I feel that focused vision, especially for semiconductor, has to be launched by GSI top process. They have to consider very seriously. Okay, does it answer your question, Girija? Are we extracting any component? Yes, we are extracting. Yeah, definitely. See, some of the elements like aluminum and copper, and they are very common there. They are available. But the only thing is, the less available dopants. Dopants are the most important, like arsenic, antimony, that type of things are very much required. That is where we are. If we have to call ourselves experts, we have to go and search the needle in the haystack. That is the sum. That's the sum up I will give now, because all these minerals, this available in very small quantities like needles. So and then Indian territory is very high, So literally we have to find out the needles from the haystack. So we have to have special missions for semiconductor elements.
Thank you, sir.
Thank you, Vadhavan Sab, and thank you, Sisiran
Vadhavan
Sab.
Please interact in person. Vadhavan Sab, please interact in person. You have to unmute.
Yeah, thank you very much, Hari Bhai. Really very informative, very insightful talk. You have made good preparations. And I must appreciate it's absolutely new field wherein you have ventured and collected so much of information and shared it with us. My interest is, in fact, it's my concern also that are we really teaching these subjects in our university courses? Are we preparing our young budding geologists to get into these material sciences? This is
So
important
far,
because we really need to teach it at the university level, and I don't know whether any of the universities or IITs is getting into it. Please elaborate.
yeah, so far we are not doing Vadhavan sir. So far, our syllabus, our syllabus, even under new education policy 2020, of course, a semiconductor mission is only 2023. So NEP is 2020. So our universities have not started doing this actually. But as you rightly said, yes, these are the niche areas. So they slowly they need to be started into they need to start introducing all these things into the syllabus. If not in the syllabus, they can conduct one-off session or maybe a 2-day session or a special course or something like that, short, or they can conduct seminars, more awareness seminars and all that, and definitely teach the students more than the students. Now what I feel is the STM spin-off STMs from the geological mapping. If you see, we all started our career in geological surveying in 1977 with 1:50,000 geological mapping. The lot of spin-offs can be done from the STM. STM is only spin-off from the geological mapping, but more focus has to be done on the this specialized thematic mapping, specifically focused towards semiconductor, then strategic elements, strategic metals like magnesium, tungsten, and all those things. That's what we have to do now. If we continue our exploration mode and geological mapping in the same old method, we will not be able to do anything much further. If we have to reorient everything, the need of the hour is constant rethinking, revisiting the places like you have seen where you are sitting, Rajasthan, Rajpura Dariba. We have, as trainees, we have visited Rajpura Dariba. We never thought of having Germanite in that. But today, I have read while compiling more, I have read that Rajpura Dariba is one of the place where we can look for a Germanite.
Yeah.
So
Yeah.
that type of things.
Thank you.
Yeah.
Thank you very much.
Yeah, you're right. In fact, GSI has to come out in a different mode, mission mode of mineral mission mode, because in orientation survey in the first year, total orientation, they have to introduce all these things requirements so that the younger geologist can take up.
Sir,
Otherwise,
even not only GSI, even AMD also should be geared up, and even state DGMs also should be
yes,
prepared
we
for
are
it.
doing, but AMD is limited to certain minerals. So therefore, only
No, this critical minerals is also a major mission now in AMD.
critical is only those who are associated with radioactivity. AMD is looking.
Right. Correct. To be fair, to be fair with the AMD, I fully agree with what Raju Gopal Mohanty sir told. Yes, you are highly focused towards the atomic minerals and rare earth elements.
And radioactivity. In fact,
correct.
But I'll tell you, I also had attended one meeting in Ministry of Mines sometime when I was in service. That time the question of lithium came in 2015, and lithium was atomic mineral. So we were saying that lithium is no more required in atomic minerals because actually lithium was requiring in atomic energy only for fusion research. So a little bit of lithium for research activity would be enough. But now since lithium battery is coming, so lithium has been taken out from the atomic minerals. Now it is open to everyone. So therefore, so we are confined to only the minerals which are radioactive in nature. Thank you. And next, my compliments from Sisir Kumar Rath and Mr. Nilesh Desai. They are also thanking compliments. Next query, probably Mr. S.P. Mohanty. He says, what are our geochemical inventories of these critical minerals in Archean and Paleoproterozoic iron manganese deposits? Oh, this is a very vast thing.
So I don't think any geochemical inventories are available. But geochemical mapping is over, sir.
Yeah.
Geochemical mapping is over. But then inventories, a lot of anomalies have come. But I am not very sure because I retired from GSI in the year 2012. And I do not know how many spin-off items, field items can be launched on the basis of the geochemical anomalies which have come out of the geochemical mapping. I am not very sure. I cannot answer because I have not been able to rather get any information on the geochemical mapping since my retirement. But then we have inventories. Our geochemical maps are available. Only thing is now we have to sit and patiently look for at ppm and ppb levels of the anomalies.
And its extractability.
Exactly.
I
Exactly.
read this question because of my interest. You mentioned germanium and gallium
Yeah.
mostly occurring as a sulfide, particularly in coal fly ash and Rajpura river deposit where
Right.
carbon phyllites are found.
Right.
So this basically indicates association in a sedimentary environment which was anoxic. So my interest on Archean and Paleopatric geochemistry stems from that. That is the period when many anoxic basins were formed. In
Correct.
fact, in one of the basin in central India, Chilpi Basin, we got very high amount of uranium as well as molybdenum. In some of the individual samples were as high as 200 times molybdenum content than crustal average, and uranium was 64 times in iron ores. And when
Yeah.
we average, maybe much less, that was the peak value. So this gives indication to look in anoxic basin, particularly where sulfidic condition, ocean condition was present.
Right. Absolutely. Absolutely. Reducing
And
condition.
since iron is deposited below redoxcline, so that is ideal target where we can look for these sulfidic elements.
Yes, sir. Yes, sir. Definitely. See, the today's knowledge on the germanium is mainly hinged to our work in Namibia and DRC, where all these minerals were available with the hydrothermal deposits. So that is the reason I told, but that doesn't mean that we should not look for. We have to see geological, we can't negate the possibility of any occurrence in any sort of geological setting. Every geological setting has to be re-looked into that, revisited, and we have to with
Now, these
focus.
these anoxic sediments can be
Good.
remobilized during metamorphism and hydrothermal
Correct.
flow.
Correct.
In fact,
Correct. Absolutely.
in
Correct.
one of the area in central India,
Yeah.
this molybdenum is found associated in calc-silicate rocks as veins, within
Right.
veins, remobilized veins.
Right.
We'll go to the next from Mr.
So,
Lalima. He says, what about vanadium?
Vanadium. Right now. I have no information about vanadium.
And that is probably not listed as a critical mineral, I believe.
No, correct.
Because
Vanadium is
government of
so
India
far.
what has said 30 minerals. Out of that, is vanadium there? Maybe.
No, vanadium is not there. Definitely, vanadium is not. But you see, I'm not sure about its employability in the semiconductor industry. That's another thing. See, vanadium, how far it can be used as a semiconductor stuff, I'm not very sure right now.
So
I will
your
do
lecture
my
was
research.
particular semiconductor, right? Sir, right. Sir,
Right.
right.
Huh?
So
Right.
next,
So I will
query
look
was
into
from,
that.
next query is from Mr. Jawahar Gujjar.
Can I?
He says, can you? I'll after finish this queries, I'll come to the next people. So he says, excellent presentation, educative, informative about utility of critical minerals, electron industry. Oh, that's a fine. That's a compliment. Then Mr. Anil Mathur, he says, so nice. In fact, it is the only compliment. Farooq Saab actually says, thank you. It's a highly informative.
Thank you.
Sarvan, good evening, etc. Dr. S.K. Singh says, for semiconductor purpose, we require the elements to be extracted in used pure form in India where we stand. Even we do not facilitate to prepare high pures. Yes, that is a basic fundamental thing in our country. In fact, we always purchase because it's cheaper and available. But now it has become critical, so therefore we have to think of all.
Yeah, correct. And of course, we have started. You see, now it's not that we are not doing ultra pure. We do have, we have facilities now that is Sanand and all the Dolera and all that which you are talking about. They have already started having facilities to make high pure silica and all that. Yeah, definitely.
Right.
Yeah.
Next is Mr. Jawahar Gujjar, I suggest you present this in our forthcoming GSI seminar. Okay, that's up to you. And then Mr. Det, I don't know who has any pilot scale study conducted for recovery of germanium from aluminum? I do not know. Okay, please.
No, not yet. Not
No,
yet.
not
So we
yet,
have to do.
to my knowledge also. Then he says again, what is or are the impact of metallurgists in the semiconductor industry? How can future metallurgists help? They are the, in fact, main people.
They are the, in fact, they are the main, they are the main stakeholders actually. They are
Right,
the
right,
main
right.
stakeholders. Yeah,
So GSI geologist will discover, but ultimately it has to, marriage has to happen between geologist
Yeah.
and the metallurgist. Otherwise, nothing can do.
Correct. I use the word mineral engineering. Metallurgists,
Metal engineering,
mineral engineering.
verification. Yes,
Today,
yes. So
mineral
it has to
engineering
be,
is more important. Yeah.
it has to be integrated approach. Then
Yeah.
I will go to the people who have raised their hands. So on first one is Mr. Dr. Subhanshu Raya. Please, you can ask any question.
Yeah, thank
Okay,
you. I must.
video. Please open the video also.
Okay, okay,
Yeah,
okay.
yeah.
Yeah,
Right.
I must compliment and congratulate my old friend Dr. Sarvothaman for this excellent and informative talk. In fact, when you are using that word doping, my mind went to that word in the athletics. It has the same effect. You know, in athletics, people are banned for doping. So, and in fact, I know my concern is because when I was working in Dr. Rajgopal Mahanti must be knowing when we were working on this uranium isotopes, that the surface barrier detectors we are using to assess the uranium 234, 238 and all that, that NP junction and your this semiconductor, all those things you had those times, some 40, 50 years back. But we never thought that it would come to this scale. But my query is, I just wanted to know, you see, we have got so much of these bauxite deposits, that aluminum is there, and we also think that gallium could be there. So any unit that is coming up to to use our resources.
I am not very sure, sir. To let me very frankly admit that I have not heard anything is coming up like that. Actually.
No, let me add, sir. Can I just add
Sure.
because there is a research center associated with Ministry of Mines in Nagpur. They are doing a lot of research on the processing of bauxite, aluminum ore, and the red mud. You know, which is very famous byproduct, which is generally discharged, and it's also a major waste which is to be handled. In fact, that red mud is actually having a lot of germanium. A lot of research is actually happening on that. But how to extract it in a viable manner, economically viable,
how
that
to
is a big
liberate
challenge.
this liberation is a very difficult task.
Yeah, so extraction technology is a big challenge, and I'm not sure what is the latest position, but I know a lot of research was happening on the red mud, and there is a positive indication of germanium there. Thank you.
And in fact, I will suggest, because of my experience in AMD, we have a mineral technology lab. So therefore, all the different deposits we also extract pilot scale in AMDA. So therefore, GSI also can think of when the only it's not only the job should not end with discovering a deposit or assessing it, but simultaneously extractability. So pilot scale studies and a laboratory for extraction, employing the metallurgist in GSI. I don't know how many metallurgists are there, but lab and metallurgists should be there, a part of GSI staff, GSI faculty, GSI.
Actually, this part of the responsibility is given to IBM. They have this mineral processing and extraction.
But at the same time, IBM is under different head. So GSI DG can implement. You do this within 1 month. Give me the result.
We are the sister organizations of the same ministry, and there needs to be a good collaboration. I agree with
that
you.
should be, yes.
There needs to be good collaboration because they are having their own full of research experts and
exactly, they escape out, sir. They escape out. So therefore,
this IMT in Bhubaneswar, they have got some fantastic facilities.
Yes, but there is no coordination. There is no coordination.
Now that they are collaborating with GSI for that RE work, and yes, they are doing now.
Okay,
absolutely.
Next is Dr. Prakash Saab. Actually, in fact, I also know him very well in Shillong days. Prakash Saab, please.
Prakash sir, good evening.
Namaskar, sir.
Namaskar.
Namaskar. Sabko namaskar.
Yeah.
I have 2-3 queries. Question is, where Dr. Wadwan left, I would like to start from there. he suggested about university education, about these things. Are we doing it in our training institute? That's for my first question. Orientation course or later refresher courses, are we doing it to meet with the situation? First thing. Second thing is, into our known metallic deposits is a very good thing. When I was in the ministry, MOM, in 2012, through the secretary's DO letter, I gave a directive to the DGGSI to start, FSP programs for REEs and critical minerals in all the states. Well, it was done, and I suggested to look into what we condemned, the known deposits on record during that time as low-grade deposits, sub-economic or uneconomic deposits, condemned. So there is a potential, there is a possibility of getting these subsidiary minor elements, and some of the deposits were re-looked into, I know, but many are not revisited. For example, in Karnataka, we have got Kalyadi, Aladalli and Ingaladal, where we looked for or prospected for only copper, drilled for copper. We did not get good values for copper. We closed the investigation. Whereas some mining was done at the deeper levels, they got high silver. In Aladalli, they got high cobalt, but did not interest the people. They have not done any work. These are the areas where these exotic minerals can be located. That's one thing. You mentioned about Rwanda and DRC. Actually, concentration of these things uh, are there in carbonatite lavas. Actually, it's a very rare type of eruption, and I have got my own experience in Mincheri area, Lingsugur Taluk, Raichur district, Karnataka, where I reported high RE values in percentage in 92, 93. But my then DIC did not encourage me. But when I became the director CT in SUKG in 2012, I launched the FSP. I introduced drilling, and we have drilled and proved it for 1.1 kilometers. The values are in percentages. Total values are up to 12%, in fact. So anyway, the report is probably under covers. That's a different thing for our own use. So there also, I found association of this anomalous enrichment of RE with carbonatite. The gang is carbonatite, and several carbonatite plugs are there nearby. And there, in this connection, I would like to suggest that the genetical aspect, the genesis, the metallurgy of all these metals have to be worked out. I am sure there is some process by which these minerals are enriched in differentiation, and I am of the opinion that most evolved granites can carry such concentrations, and that is possible when there are younger granites in our country. Where are the younger granites? Where are the 1 million and 2 million old granites? We have, at the most 650, 700 million year old granites. But where are the latest granites, most evolved granites? You are an expert in granites, Sarvothaman Saab. So, where are the younger granites? Where are the most evolved granites? Those are the locales,
those
and
areas
also
have been-
carbonatites.
Yeah.
These are the things. Kindly throw some light on this.
Yeah,
and
sure.
Mr. Farooq, next is Farooq Saab is asking at what stage gallium can be extracted from bauxite, and at what stage? Okay, gallium can be extracted from bauxite or red mud. Please.
Yeah,
Yeah,
may I expand it? Because I just want to know, gallium is also gallium. I mean, red mud is considered as a source for gallium, but is it possible to extract before it reaches the stage of red mud?
yeah, that's what I told in the see. We have to do some innovative mining in the process of mining the bauxite to so that the gallium does not. You see, there are ways of I don't know how it should be done. It's really tricky. It's a tricky.
Can I just add here, sir?
That will,
Yeah, please.
Farooq
Yeah,
sir,
please.
Dr. Saab, the gallium is being extracted there's a process called Bayer's process, Bayer's liquor.
Yeah.
I
Okay.
do not know the details, but this is how the bauxite is transformed into alumina, right? And aluminium metal. So in that process of extraction, gallium is actually separated. But to what extent and to what economic levels, those
Yeah.
details I do not know. But this is being done actually. It is not anything new. I had learnt it nearly 1.5 decades earlier. Now the technology must be much more advanced. As
Yeah.
Hari Bhai is also elaborated, now the people are more concerned. Therefore, the necessity is the need of invention. So many more new things must have come up, and
Correct.
this extraction process must have been, technologically evolved. And of course, there has to be a good marriage, as Hari Bhai has said, between the geologist and the metallurgist, the extraction
Metallurgists
technologist.
and also the mineral engineers. Mineral engineers who are those who are going to extract at the PPB and PPM and PPB
Uh,
level actually,
yeah,
because
we
they're
call
all
it
very
we call it mineral processing here.
yeah.
And at the same time, I feel that some of the people, scientists, should be interacted with the other bilateral collaboration with other countries who are
Right.
producing gallium. So therefore,
Absolutely.
interaction are bilateral
Correct.
because the technology is evolving every month. Every year it is evolving. So bilateral
Right.
collaboration at the extraction level should happen, and then probably in our country enough resources are there. So sir.
Yes, yes.
Right.
Can I
Absolutely.
add one request?
Yeah,
Can I
yeah.
come in?
Please, sir.
Yeah, Dr. Sarvothaman, for
Sir.
this brilliant presentation, if you give us a note on writing in the form of a paper, in the SGAT we have a bulletin where we can publish, and it will reach a wider group of scientists.
Sure.
That's a
Can we
very good
expect?
suggestion. That's a very good suggestion, sir. I fully
Thank you.
support it. So Hari Bhai, please write a detailed note
Yeah.
Okay.
for this.
Thank you.
Okay.
Thank
Okay.
you,
I will
Dr.
do that.
Sarvothaman.
I will do that. Definitely, I will do that. But you have to give me my time, because now the academic sessions starts in the University of Hyderabad, where I have a commitment to teach. That it starts in the first week of July.
Will
So
3 months be okay for you? 3 months program?
maybe yeah. I will. I should. It should be. I should be able to do that. Actually, let me
4
see.
months?
Definitely.
Well, my question is not answered, Dr. Sarvothaman.
Yeah. Please tell me. Yes, sir.
Yeah, where can we expect most evolved granites in
Yeah.
our
See.
geological environment?
Yeah. See, as we discussed, most of these are under the hydrothermal, sir. Actually, Prakash sir, these are all German, especially the Germanite is available in the skarns and the hydrothermal deposits in Namibia and DRC. So that is the reason. First comes, yes, when it's a proven thing. We are going from known to unknown. When things are already established in the DRC and Namibia that they are associated, that is the reason I said that we have to look into the hydrothermal. But that does not mean that we should not look into the other rocks. Definitely, see, younger granites are definitely they are rich in RE and several other younger molybdenum, so many boron, everything. Today boron is also a big dopant. And where do you get boron? With so many with so many minerals, boron is available. Even tourmaline has a lot of boron. So tourmaline is available with the pegmatite. So in our geological mapping in 77, which we considered as a very unimportant, they turn out to be very important today. That's what I wanted to
Okay.
tell actually. Yeah.
Okay. Can we do geological modeling under MAVAM, mineralization associated with acid magmatism?
Sure.
All these elements are highly, they come at the late stage of differentiation.
Yes.
And that enrichment is possible in evolved granites, most
correct.
evolved granites. So where can we prospect for these things in our setup?
That's what we have to revisit, sir. As I was telling, all these areas need to be revisited to launch recent studies in recent trends actually. All these things. See, we
Yes.
should not look into, we should never say that, yes, if it is already done, I have already mapped, I have proved. No. Now today, the everybody is talking about the zero waste. So there should not be any wastage in any of the stuff. So even the youngest things which are called as the veins, the quartz veins need to be studied. The pegmatite veins have to be studied for germanite and REA. Rare earth elements are concentrated mainly in the pegmatite veins in most of the places. So whenever in 77 and all that, whenever pegmatite veins are there, we have recorded them as pegmatite and then we forgot it. Now we have to, it is the time we revisit all those areas and see whether any rare earth and things like germanite and all that, they are available in that.
Thank
Okay,
you.
so yeah.
I was working on actually Salal project. Salal lithium created a sensation all over the world, but I ruled out the possibility in a seminar. See that Salal concentration of lithium in bauxite is possible from the washings from granites in that area. Such highly evolved granites could be there in the central Himalayas. Where ice cover is not there, we will have to cover such areas. Otherwise, in rest of the country, where only some academic interests are there, but economic interest is not possible, in my opinion. Other than metallic deposits of Archean age or Proterozoic age, what we have discussed so far, Zawar lead and zinc deposits or Ingadal copper deposits, such deposits. But for actual deposits, we will have to work on carbonatites and evolved granites. Thank you.
Yeah.
Okay, thank you so much. Now almost everybody has been interacted. It was a wonderful interaction. In fact, this is actually, as Dr. Jadavanand Das initially said, this is a fraternity lecture. Fraternity lecture is Bhaichara lecture. So Bhaichara means all the Bhais together, they discuss about some issues in the critical mineral sector. We have a wonderful presentation we had. And before I give it to Dr. Jadavanand Das, can I request our SGAT President Khuntia Sahib, are you there? Khuntia Sahib, are you there? Or he has left? Hello?